All right. There we go. We are on this page right here. You are going to need to have your calculator handy, ladies and gentlemen. For these problems today, we are learning another special relationship in the triangle. And before we get to that new relationship, new interesting factoids, we're just going to do a quick review of the parts of a right triangle here. We have a right triangle. How do we know it's a right triangle?
Right angle.
It's got a right angle, a 90-degree angle. Very good. Very important. And, I do highly recommend that you got some colors on your desk, okay? So if you don't have your colors, get them out. Get them out of the cabinet there.
How many colors?
2 would be great. 3 would be also great. Okay. All right. Let's go. All right. Looking at this triangle, ladies and gentlemen, what are sides A and B called? Legs. Very good. Legs. What is side C called? The hypotenuse. 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 All right. It is very, very important today that you always hunt for the hypotenuse first, okay? The order of the legs don't matter. The hypotenuse is the most important part, and it is hard to see today. That's exactly right. The hypotenuse is across from the right angle, so very important there. Now, the Pythagorean theorem is used to find a missing side length on a right triangle. Very good. And what is the formula for the Pythagorean theorem? A squared plus B squared equals C squared. And again, that hypotenuse is the most important thing. We're always equal to the hypotenuse squared. So I usually say leg squared plus leg squared equals hypotenuse squared. The order of A and B does not matter. So very quickly here, looking at number 1, what is the hypotenuse in this picture? X is the hypotenuse. So what formula can I write down to figure out the value of X? 8 squared plus 7 squared equals my hypotenuse squared. Very good. 8 squared plus 7 squared equals the X squared. Do I expect to see an equation like this every single time?
Yes.
I do. Can you do the rest on your calculator? Yeah. Absolutely. Okay. But we're going to go through and work this out. What is 8 squared? 64. And 7 squared? 49. What is 64 plus 49? 113. Very good. 113. There we go. Is equal to X squared. How do you get the X by itself? You square root both sides. All right. So in your calculators, you are doing the square root of 113, 10.6. For all of our answers here, anytime you need to use your calculator, you're going to round to the nearest tenth. Ayrton, quiet, please. You are going to round to the nearest tenth. Okay, so what do we get for X here? 10.6. And what are the units on that length? Inches. Just inches will do. Just talk about length, not velocity. All right, let's just do one more here. Let's look actually at number 3. All right, ladies and gentlemen, what is the hypotenuse? 13 is the hypotenuse. Identify that first so that you can correctly set up your Pythagorean theorem. What should we write?
6 squared plus x squared equals 13.
Very good. 6 squared plus x squared equals 13 squared. Again, always equal to the hypotenuse squared. Very important. So we have, what is 6 squared? 36 plus x squared equals 13 squared? Very good, 169. All right, so I'm going to go ahead and subtract 36 from both sides. So we get x squared equals, let's see, 133, huh? 133?
Yep.
And then we need to do what? Square root. Take the square root, very good, of both sides there. So the square root of 133, x equals 11.5. And what are the units on that? Centimeters. Very good. Always a good idea if a problem gives you units to attach units to your answer. Just excellent. Do you have questions for me? No. Unless I say include units in your answer specifically. I'm always very specific, so you don't have to worry about that. Questions on Pythagorean theorem? Raise your hand if you're 100% confident in Pythagorean theorem. Okay, great. Now we're going to hide that in a giant, crazy triangle. Here we go. All right. This is a new relationship. Here we have a picture, crazy picture right here. So we're going to use our colors to kind of help us sort everything out here. So to get us started, I'm going to use red here. No, I'm going to use blue. All right, here we go. Here we have a picture. We're going to talk about the circumcenter. The perpendicular bisectors. Perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. All right, so what I want to do is I want to take my colored, in this case blue, and I'm going to identify these perpendicular bisectors. So, for instance, EP is a perpendicular bisector. How do I know it's a perpendicular bisector?
Right angle.
Yeah, we got a nice little right angle there, and we can see that it bisected the side. So PE is a perpendicular bisector. What's another perpendicular bisector? PF is another perpendicular bisector. And PD, very good, is another perpendicular bisector. Okay, which means those perpendicular bisectors are intersecting at point P. Point P is called the circumcenter. So the circumcenter is point P on this picture. Now, why is it called the circumcenter? Circumcenter maybe is reminding you of a word like circumference or circle. Do you hear the similarities? Okay, circle, C-I-R, and circumference. And what that means is that point P is the center of a circle. P is the center of a circle circumscribed around the triangle, which means I can connect a circle. A circle will pass from the vertices all to each vertex of the triangle. It has this nice little circle that goes around this triangle. Do you see the circle? Yep. Okay, it's a very cool circle. That means the circle is circumscribed around the triangle. Okay.
Is this like one of the things that like make a circle and right in the middle is kind of like all right?
Yes. A compass. You could take a little compass and measure this is the radius, and it would spin perfectly around. Okay, and hit these vertices. So we can read that here. The circumcenter is always equidistant from the vertices of the triangle. Shh, gentlemen. Yeah, that's not where they're supposed to sit. All right. We have a circle. A circle means from the center to the edge of the circle, to the right there, point B. That is the radius. Yeah, this is red now. I've got a red pen here. And the center to point A is the same radius. And from P to point C, that vertex there, is all a radius, like the spokes of a wheel. So this is, imagine the wheel, and we've got a little axle right in the center, and that's your the spokes of a tire, okay, on your fat tire bike, whatever you got. We'll get there. These red spokes, the radii of the circle, are all the same length, okay? And so they are all congruent segments. PB is congruent to PC, is congruent to PA. From the circumcenter to the vertices are always congruent. We, of course, have other congruent segments as well, but they're already marked here. All of our sides of our triangle were bisected, so those are congruent. Got another pair of congruent pieces. I don't need to list anymore, okay? When we are told that we have a circumcenter, we have to be able to remember that it's formed with perpendicular bisectors and that it's inside of a circle. So I hope that you can remember circumcenter means draw a circle around it, all right? And that's going to help you figure out where these red radii are, okay? So let's try some. And again, we are going to round to the nearest tenth, if necessary. Round to the nearest tenth. We want to find each measure. And we've got to make sure we're reading very carefully. In this picture, we have Z is the circumcenter. So I'm going to take my red pen and denote that circumcenter, and remember, if it's a circumcenter, then I can inscribe or circumscribe a circle around there. That was not a very good circle. And then see that my radii go from Z out to my vertice there. So ZU, ZV, and ZT are all the same length. So I totally encourage you to use a color to recognize that they are all the same length, okay? Now I'm going to get a different color because I also need to mark up my perpendicular bisector. So give me, which one of these lines is a perpendicular bisector?
None of them have ratings.
Well, you're right, it's not indicated, but they told us using the word circumcenter. Because it's a circumcenter, I must have perpendicular bisectors and congruent radii. So where are the perpendicular bisectors? ZY is a perpendicular bisector. ZX is a perpendicular bisector. And so again, I'm marking it based on a single word. Okay, that word has a ton of meaning. Where's my other perpendicular bisector? ZW, very good. Okay. All right, so all that information comes from one single word, very important. And I really encourage you to use colors to help just identify stuff. All right, the other thing here gets a little bit wonky is you see where we have a 15 and the 21? What is the 15 referencing? The green line, WZ, very good. And the 21 is referencing ZV, the length here of that red line, okay? It would be an angle if it had a degree symbol, okay? All right, so how do we find TU? TU is up here. How do we find TU?
You double 19.
Yeah, we can see we've got 19 marks. The other side, 19 plus 19 is? 38. Very good. VY. Where is VY? VY. We're right here. VY is right here.
Half of 34.
Half of 34. The whole thing is 34. We've got two congruent parts. 34 divided by 2 is 17. Very good. Again, I encourage you to write stuff down. All right, now UZ. UZ is this red line. How long is the red line?
34. 21.
It's 21. 21 is this red line ZV. All three red lines are the same length. It is 21 because it is a red line. All those radii are the same length. Okay, then WV. WV is right here. And I need to figure out that length of WV. How am I going to find WV? Do I have a right triangle? Yes, we do. We have a side length that's 15. We have this pink side that I'm trying to figure out. And we have a red side, which is 21. So what can we do to figure out that third side? A squared plus B squared equals C squared. So we should have 15 squared plus X squared equals 21 squared. You have a right triangle. You must recognize the hypotenuse there. All right, what is 15 squared?
225.
225, very good. Plus X squared and 221 is 441. We need to do what? Subtract 225. So we get X squared equals 216. Very good. And then how do you get X by itself? Square root. Very good. So we get X equals 14.7. Very good. And so that's this length, 14.7. I'm going to go ahead and write that in, 14.7. Very useful to write on your diagram. And now the last thing, TV.
Double it.
Double it. Very good. TV is the whole thing. So all we have to do is 14.7 plus 14.7, and that is 29.4. Okay. Questions on this?
No.
Okay. Let's do another. Okay.
There was a block party of Braden yesterday.
H is the circumcenter. If H is the circumcenter, what do we know?
It means circle.
They mean circle. There's a circle connecting those vertices. All right, so what segments are congruent?
HC, HD, and HB.
HC, very good. HD and HB are all congruent. How long are all of those red lines?
13.
They're all 13. All the red lines are the same.
Oh, yeah.
What else should we mark on our picture? What is HG?
HG. Oh, that is a perpendicular bisector.
Perpendicular bisector. Perpendicular bisectors. HF and HE. Okay. So we've marked our perpendicular bisectors and our congruent red radii. The first thing we need to do is find Ayrton. Move back to your seat. GD, where GD is right here. How long is GD?
GD is 12.
How'd you get 12? 24 divided by 2. Very good. 24 divided by 2 is 12. BC. BC is this whole length here. BC. What's BC? How'd you get 14?
There's a 7.
7 plus 7 is 14. Carly. EH. EH is right here. It's this green line. How do we find the length of that?
That's
right triangle. Yes. We have a right triangle where one side is 7. What's the red line?
the hypotenuse is 13.
It's 13. All those red lines are 13, and here is that side EH that we're trying to figure out. Okay, so how do we set that up? Okay, this is 13. Sorry. My pen is out of ink, it appears to be.
I can't see.
Soldier down.
It says 7. You got that? 7.
Wow, that really couldn't show that. Sorry. Alright, 7 squared plus x squared equals 13 squared. Sorry. Alright. Okay, this is 14 and 12. Sorry, my pink pen ran out of ink. Alright, we have 49 plus x squared equals 169. We're going to subtract 49 from both sides. That gives me x squared equals 120.
Whoa.
And we need to take a square root. What'd you get for x? So, okay, it is, yeah. The square root of 120 is 10.95. If we round to the nearest tenth, it says go up one, so we got to be 11.
That's fair to you, Jedi. You were just a bigger brain. I'm sorry.
All right. FD. How are we going to find FD? FD is right here.
Good. Is there a right triangle?
There's a right triangle again. This is a little skinny guy right triangle. Hello.
Hey, what's wrong with being skinny?
That is a 3, and we don't know. I'm going to call it an X. And what's the red line?
13.
13. Very good. So what should we set up our Pythagorean theorem as? 3 squared plus 13 squared equals, no, that's not right. 3 squared plus x squared equals 13 squared. Gotta know the hypotenuse is that red line. Alright, so we have 9 plus x squared equals 169.
Yeah.
Subtract 9.
Yeah.
And then the square root of 160 is?
Big number.
12.6. Very good.
Big to me, okay?
Alright, again, I'm going to write that on my picture just so it helps me later.
Will it help me later? It'll help you now.
What is CD?
CD is 12.6.
12.6 times 2, 25.2. Okay. Are you good? Do you think you got it?
I'm happy.
Okay, very good.
Yeah, real good.